Hello everyone, section 9.2, special right triangles. Example 1, find the value of x. We're going to put this answer in simplest radical form. So hopefully you now know that the relationship between the hypotenuse and the leg in a 45, 45, 90 triangle, even though this is told to be a 45, 45, 90 because it's isosceles, has to be 45, 45. So the hypotenuse x is equal to the leg times the square root of 2. So 22 square root 2 is part A. Part B, we're told the hypotenuse, we're looking for the legs, which again we're noticing that they're both the same, must be a 45, 45, 90 again. So if the hypotenuse is 10 square root 2, then the leg had to be 10. So 2 on to 30, 60, 90 right triangle relationships. Find the values of x and y. This time we're told this is 60, this is 90, so this must be 30 degrees. So if this is a 30, 60, 90, we know that the short leg is half of the hypotenuse. How do we know which one's the short leg? It's going to be opposite the 30 degrees. So y is 30, is the short leg, and that's going to be half the hypotenuse. So y is equal to 15. And the long leg is the short leg times the square root of 3. So x is equal to 15 square root of 3. That's example 2. Example 3, warning stickers in the shape of an equilateral triangle, which each side length is 4 inches. The estimated area of the sticker, estimate the area of the sticker by finding the area of the equilateral triangle to the nearest tenth of an inch. Because it's equilateral, each of these angles is 60 degrees. And if we draw in the altitude or height of this triangle, that's going to break this angle 30 degrees, breaks this side into 2 and 2 because it was 4. It also makes sense that this is now 30, 60, 90, and the short leg is half of the hypotenuse, 2. Makes the height of the triangle 2 square root 3. An area of a triangle, 1/2 base times height. 1/2 base is 4. The height we just calculated is 2 square root 3. Half of 4 is 2, times 2 is 4, square root 3 inches. We're looking for this rounded to the nearest tenth of an inch, so we pull out our calculators. And 4 square root 3 is approximately 6.9 inches squared, inches squared for the area of this triangle. All right, example 4. A tipping platform is a ramp used to unload trucks. How high is the end of the 54-foot ramp when the tipping angle is 30 degrees? So we want to know, so this here is 30 degrees here. The ramp is 54 feet. So we're going to change this to 54 feet, not 80 feet like it is in the diagram. So it's 54 feet, which is here, 54 feet. We want to know the height of the ramp, which is the short leg, opposite the 30 degrees, so it's half of the 54. So the height of ramp is equal to 27 feet. And that's example 4. Example 5 is filling in this chart with the given information for each of these new triangles. So we're told that angle Q is the right angle, R is the 30 degrees. So if R is the 30 degrees, then PQ is short leg. If Q is the right angle, then PR is the hypotenuse. And that means QR is the long leg. Okay. To go from hypotenuse to short leg, we divide by 2. 5. To go from short leg to long leg, we multiply by square root 3. 5 square root 3. To go from long leg to short leg, we divide by square root 3. To go from short leg to hypotenuse, we double it. Again, when we go from long leg to short leg, we divide by square root 3, but this time there isn't a square root of 3 in there, so we have 8 divided by square root 3. Now, your algebra teachers are not going to let you leave this as a square root in the denominator. The truth is there's no reason why you can't leave it as a square root in the denominator, but the algebra teachers insist on us rationalizing the denominators to 8 square root 3 over 3, making the hypotenuse double that, or 16 square root 3 over 3. Well, we know the hypotenuse is 14, the short leg is 7, and the long leg is 7 square root 3. All right, we're going to do something similar in example 6. This time we have a 45, 45, 90. E is the right angle, making DF the hypotenuse. If DF is the hypotenuse, these are the two legs, and they're both the same, no matter what. If you know the leg is 5, then the hypotenuse is 5 square root 2. 2/3, then we know the hypotenuse is 2 square root 2 over 3. To go from hypotenuse to the legs, we divide by square root 2. So again, we're going to run into 7 over square root 2, and algebra teachers are going to make you rationalize that. When, again, the truth is you don't need to in the real world. Calculus, you're not going to need to, but the algebra teachers, they start twitching if you don't rationalize denominators. So to make them happier, 7 square root 2 over 2, 7 square root 2 over 2. 4/5, so 4, so 4 over 5 square root 2 becomes 4 square root 2 over 10, which reduces down to 2 square root 2 over 5. 2 square root 2 over 5. That was example 6. Example 7, our goal is to find the value of x, which means we're going to have to start way over here and work our way down to getting the value of x. So 9 square root 3 is the long leg. It's opposite the 60 degrees. So if the long leg is 9 square root 3, then the short leg is 9. Hypotenuse is 18. If the hypotenuse is 18, for 45, 45, 90, we divide by square root 2. X equals 18 divided by square root 2. Rationalize that denominator, 18 square root 2 over 2, or 9 square root 2. Example 8. In a regular hexagon, we have AB is 8, which means all the sides are 8 because it's regular. Our goal is to find the length of AC and the length of AD. Okay, so it's pretty cool here. It's a regular hexagon, and you can do out the n minus 2 times 180 and then divide that by 6, and you're going to find that each of these angles, interior angles, is 120 degrees. Of course, you could also do 360 divided by 6 to find the exterior angle is 60, and the interior angle is supplementary to it. Either way, you're going to get 120 degrees for the interior angle. That's 120 degrees here. which mean, and this is isosceles, 8, 8, which means these angles here and here are congruent. If they're congruent and they have to add up to 180, then we have 60 left to add between the two angle A and angle C here, making each one of these 30 degrees. Okay, this is one way we can find AC. See if we can find another way in a second. If this whole thing is 120 and this is 30, 120 minus 30 means that this angle right here is a right angle. This AD is bisecting angle CDE, making this 60. 60, 90, 30 degrees here. Okay, so we now have all these relationships. To eventually get AC and AD, we're going to have to bisect this angle B here, drawing in an altitude right here, making this 60, 30, 60, 90. This is 8. This is 4. 4 square root 3. AC is 8 square root 3. I'll go through that one more time. 8, 4, 4 square root 3, 8 square root 3 for the whole thing. The long leg is 8 square root 3. We know this is 8. 16. Now it probably would have been quicker. 8, 16, 8 square root 3. Either way, we get the two answers. That's example 8. Example 9 is another chart that we're going to fill in. TU is 7 this time, making 14, sorry, wrong place. 14, 7 square root 3. 14 square root 3. And UV is going to be 7 to 21. The 7 square root 3 times the square root 3. Square root 3 times square root 3 is 3. Times 7 is 21. So now let's fill all these in. UV is 21. TV is 28. 7 plus 21. WT is 14. WU 7 square root 3. WV 14 square root 3. Okay. These relationships are going to work every single time for all of these, no matter what. So 8 square root 3 for TV. 8 square root 3. If this is 30, if this is 60, this has to be 90 in here. Okay, making this the hypotenuse, 8 square root 3, making this the short leg, making this 4 square root 3. If this is 4 square root 3, the short leg, this is going to be the long leg, which is 4 square root 3 times the square root 3, or 4 times 3, 12. This is the hypotenuse. This is a short leg. 2 square root 3. 2 square root 3, 8 square root 3, 6 square root 3. We can get that another way in a second. 2 square root 3 times square root 3 is going to be 2 times 3, or 6. And 6 times the square root of 3, 6 square root of 3. Two different ways to get this one. Okay, now let's start filling these in. TU 2 square root 3, UV 6 square root 3, WT is 4 square root 3, WU 6, and WV is 12. Okay. Relationship between WT and TV. It's half. So this is 100. Relationship between WT and WV is multiplied by the square root of 3. 50 square root 3. Relationship between WV and WU is half. 25 square root 3. Relationship between WT and TU is half. 25. These two have to add up to be 100. 75. If this is 7, this is 14. If this is 14, then this one here is 14 divided by the square root of 3. 14 over the square root of 3, or 14 square root of 3 over 3, making the algebra teachers happier. This is double that, 28 square root 3 over 3. What was the relationship that we were able to find here? Half of WT is TU, so 7 square root 3 over 3. These two have to add up to be this one, so 21 square root 3 over 3. Right. Example 10, explain why any triangle having side ratios 1, square root 3, and 2 must be a 30, 60, 90. So, we're talking about a triangle that has, let's try it like this, 2x, 1x, and square root 3x. This side is always going to be half of this side, no matter what. And this side is always going to be this side times the square root of 3. This is the definition, or this is the theorem for theorem 9.5, the 30, 60, 90 triangle theorem. So that the hypotenuse is always double the short leg, and the long leg is always the short leg times the square root of 3. And if the sides are in this ratio of 1, square root of 3 to 2, then it has to be a 30, 60, 90 right triangle. All right, the sum of the lengths of the sides of a rhombus is 64, and one of the angles is 120. Find the lengths of the diagonals. So if the rhombus's sides all add up to 64, then each one of them is how much? So 64 divided by 4 gives us 16, 16, 16, 16. One of the angles is 120 degrees. I don't know the value of the other angle yet. if I draw in the diagonals, we know a few things. One, we know the diagonals of all rhombi are perpendicular. And we know because it's a parallelogram, opposites angles are being bisected. So 60. That makes this 30. So if this is 16, this is 8. This is 8. This is 8 square root 3. This is 8 square root 3. Lengths of the diagonals are 16 and 16 square root 3. Find the area of each figure. When the answer is not a whole number, we're going to round it to the nearest tenth. If this is 24, these are 45, 45, 90s. So this is 24 over the square root of 2, or 24 square root 2 over 2, or 12 square root 2. Area of a square is 12 square root 2 squared, or 144 times 2, 288 square feet or feet squared. For part A. Part B, draw in the height of this parallelogram. So we need to know the height, because area of a parallelogram is base times height. Base is 6. Height we need to find. This is a 30, 60, 90. This is 6 and this is 60. And this is 3. And this is 3 square root 3. So now the area of our parallelogram is equal to 1/2 base times height. 1/2 6 times 3 square root 3. Half of 6 is 3. 9 square root 3 meters squared is the area of this parallelogram. That's example 12. Example 13. Find the length D that goes from the bottom left corner to the top right corner in simplest radical form, the diagonal of the cube with sides given. So if each side is 1 by 1 by 1 by 1 by 1, this is 1 and this is 1, then this diagonal in the denominator, in the bottom of the cube here, is square root 2. This is square root 2. This is a 1. Then Pythagorean theorem is going to get us D. So we'll do that one over here. D squared is equal to 1 squared plus square root of 2 squared. D squared is equal to 1 plus 2. D squared is equal to 3. D is equal to square root of 3. Do we have units? Just units. For part A. For part B, we change these 1s to 2s, making this 2 square root 2. Now, D squared equals 2 squared plus 2 square root 2 squared. D squared equals 4 plus 4 times 2. D squared equals 4 plus 8. D squared equals 12. D equals, write it over here. This time D is equal to 2 square root 3 units. I'm seeing a pattern. Now, change the 2's to S's. S, S, S. So my prediction here, D is going to equal S square root 3 units. That's my prediction based on the pattern. This makes this S square root 2. And we're going to do the Pythagorean theorem one more time. We'll go back over to the left side here. D squared equals S squared plus S square root 2 squared. D squared equals S squared plus 2S squared. D squared equals 3S squared. Square root both sides of that, and again we do get S square root 3 units. Alrighty, example 14. Find the area of an equilateral triangle with an altitude of 1 unit. Leave your answer in simplest radical form. So I'm going to draw a small version of this off to the side here. We have an altitude, 1 unit. It's equilateral, so all of these angles are 60, 60. This one's being bisected, so this is now 30 and 30. If this is 1, this is the long leg. To go from the long leg to the short leg, we divide by the square root 3. 1 divided by square root 3, or square root 3 over 3, making the algebra teachers happier. Making the hypotenuse 2 square root 3 over 3, or the base of this triangle to be 2 square root 3 over 3. The area of a triangle is equal to 1/2 base times height. 1/2 base is, we just calculated, 2 square root 3 over 3, and we were told the height is 1. Half of 2 square root 3 over 3 is just square root 3 over 3 units squared. Use relationships among the lengths of the sides of a 30, 60, 90 triangle to find the formula for the area of an equilateral triangle in terms of h for the altitude. So instead of having a 1 here, we would have an h here, which means we would have an h here, an h here, and a 2h here. Put that in there. See that 2, sliding it over. 2h here. I would have a 2h here. Area of a triangle equals 1/2 2h square root 3 over 3 times the height is h. So I would have a 2h square root 3 here, but I would also have an h here. We can't forget that last h. These 2's cancel. I'd be left with h squared square root 3 over 3 as a formula. Use your formula from part B to find the area of a triangle with an altitude 6 units. So 6 squared square root 3 over 3, 36 square root 3 over 3, or 12 square root 3 units squared. Our answer to part C. That's it. Thank you very much. Bye.